Hello, so let us look at number 4 here from year 2009, Form A. Now, we have two functions given, y equals 2x. This seems to be y equals 2x. And the bottom one becomes y equals x squared. Now, find the area of R. That seems to be quite easy. And in this case, we cannot use calculators. So here we have area R will be equal to, from 0 to 2, upper function minus the bottom function. So we have 2x minus x squared dx. Then what do we end up getting? Here we have x squared, and the second one becomes x cubed over 3 from 0 to 2. Once you plug in 2 here, we end up getting 4 minus 8 over 3. Minus, when you plug in 0, we end up getting 0 itself. But once you evaluate this one, this becomes 4 over 3. So that becomes part A. Let's look at part B. The region R is base of the solid. In this case, the cross-section is perpendicular to x-axis. That's important. Perpendicular to x-axis, some sort of in this way. Then we know that we'll be using dx. And then has the area of this much. Find the volume of the solid. In this case, many other cases they're asking us to find the area, such as area of square, area of rectangle, or some sort of other equilateral triangle, or so forth and so on. But in this case, they gave us the area. So all we have to do is, in fact, part B, integral from 0 to 2 of the volume of that particular solid is the collection of the areas. In other words, sine of pi over 2x dx. Now what do we end up getting in this case? That becomes antiderivative of sine becomes, as we all know, it becomes cosine. So cosine, but we shouldn't forget the negative of pi over 2 x and divide by pi over 2, which goes from 0 to 2. Now, then in this case, if I have to rewrite this one, we'll end up getting negative 2 over pi cosine of pi over 2 x. 0 to 2. Well, once you plug in 2, we end up getting cosine of pi. What is cosine of pi? That becomes negative 1. So we end up getting 2 over pi for the first value. But when you plug in 0, we end up getting cosine of 0 becomes 1, but minus negative becomes another positive. So we end up getting plus 2 over pi, which we end up getting 4 over pi as our answer. Alright, let us look at part C. Another solid has the same base R. For this solid, cross-section is perpendicular to y-axis. Okay, in this case it's perpendicular to y-axis. That means we're looking at some sort of in this way. Chances are they will be using dy. That means function has to be expressed in terms of y. But we'll see how it goes. Squares, right? But do not evaluate the integral. So in this case, what happened to y equals 2x? Yeah, it becomes x equals y over 2. Relatively simple. Y equals x squared. In this case, x becomes square root of y. Alright, now then here we have the volume becomes, since it's a square, we have to simply find the side of the square. What is the side? It will be from right minus left. Right becomes this one. In other words, we're going to get the square root of y minus y over 2. That becomes the side of the square, which we have to square and dy. But how does y behave? It goes from 0 all the way to 4. So 0 through 4 becomes our answer. Alright, see you later. Bye.